In the previous video, we have fixed the issue when our bullets were flying outside of the play area or that our enemies were hit together when we wanted our bullet to only hit one enemy. Now this is all great, and now what we would like to implement is some kind of time freeze effect. Sometimes it is used before the enemy is actually shot or being killed. We freeze time for a split second so the player can enjoy this little anticipation effect before the action continues and the effect is shown. And to implement this, I think the best way to do it will be to implement a singleton. So let's quickly take a look what singleton pattern is. So singleton pattern in software engineering is a pattern that restricts the instantiation of a class to one single instance. This is useful when exactly one object is needed to coordinate actions across the system. Why do we need it, anyways? Well, now let's take a look at the time documentation for Unity. And what we can see is the time class is in Unity Engine the interface to get time information from Unity. It gives us time scale, the scale at which time passes. This can be used for slow motion effects. So what I would like to have is one instance of our class that will take care of changing the time scale. So we only change it in one space so that we are sure that we at some point will return to value 1 for the time scale, so the value that is the default value for the time flow. So let's go back to Unity. Okay, we are back in our project. What we can do is let's delete one of those charts that overlap each other. And what we can do is we can create a new class. And I think we are going to go to our scripts folder and to our feedback folder, or we can create it in our scripts folder because it will be the general class for the whole project. So what we are going to do is right click, create a new C# class, and let's call it time controller. And let's open this script up. So as I have mentioned before, we would like to make this time controller a singleton, so each feedback that wants to access the time will have to talk with the time controller, and this in turn will only talk with the time for Unity so that we can maintain the time scale to always come back to 1 at some point. So let's delete the update and start methods. What we are going to do is make sure that this is a singleton by creating public static time controller, so the same name as the class name. This will be called instance. Okay, and to create this we are going to call awake function, and on awake we want to check if instance, so the static method instance, equals null. We are going to make sure that the instance equals this, and we are going to create else if our instance is not equal to this object. So we have already created an instance object, the time controller object, and we have another time controller object somewhere. We want to call destroy, and we want to destroy this. So this should destroy only the component time controller that is a duplicate. So here what we will want to have is ability to reset and set the time scale. So let's create another public void. We are going to call reset time scale method, and we are going to simply call here a stop coroutine, stop all coroutines on this object, and we are going to set time dot time scale equals 1. Now this might look familiar with the feedback class that we have created, but we do not want to use it here because we are going to call from feedback, from type freeze feedback, our time controller, and this will deal with setting and resetting the time scale. Now what we will need to have as well is a way to modify our time scale. So let's create public void modify time scale. Okay, and we are going to pass here a float and time value. We're going to pass float time to wait, and we are going to call action, and we are going to pass here and delegate action, alt enter on action to import using system library that will be imported at the top here. And this, as you might recall, is just a way to access a method that we pass here so that we can rerun our modified timescale to go back to our basic time value, so 1. What we are going to do is we're going to call it onComplete, maybe onComplete handler, or maybe onComplete callback, equals 0 equals null. Okay, this is similar to what we have already created, I think in one of those feedback classes. And what we will need to do is call a coroutine here. So let's create IEnumerator coroutine. Let's call it timescale coroutine. And let's pass here our float and time value. Actually, we can copy the parameters from our modified timescale. Okay, together with the action. But don't set the default value for the action. And we are going to call in this coroutine yield return new wait for seconds real time, and this suspends the coroutine execution for the given amount of seconds using the unscaled time. So this will not be affected by the time scale that we are modifying, giving us the possibility to actually control in real time what will be the time that we wait. So this is pretty important. Let's pass here our time to wait. Next, we are going to set time.timescale. We are going to set end, and I think I have misspelled it in both places, so end time value, okay. And we are going to call our onComplete callback question mark to see if it is not null. If it is not null, we are going to call invoke on it. Okay, great. And now, last thing that we will need to do is call this coroutine in our modified timescale. So we are going to call start coroutine, and we are going to pass here our time scale coroutine and pass here the end time value, our time to wait, and our on complete callback. And that will be it. Now the last thing that we will need to do is actually create a feedback class that will use this time controller class. So let's save this. Let's go back to Unity. Okay, the scripts will compile, and what we are going to do is create simply a new game object in our scene. So right click in the hierarchy, create empty. Let's rename it to be time controller. Enter. Reset the transform just to be sure that it is reset, and we are going to drag our time controller script here, and this will be it for the setup for the time controller. Ctrl S to save the scene, and now we are going to go to our script, to our feedback, and let's create a new C# script. Right click, create C# script. Let's call it time freeze feedback. And let's open this script up in Visual Studio. Okay, I think I have misspelled this. So selected Ctrl-RR and you can rename it, enter. And now the class should be renamed as well in Unity. Let's save it. What we are going to do now is we are going to, of course, delete the update and start methods, and we are going to extend not model behavior but feedback, and Alt-Enter on the time freeze feedback to implement the abstract methods. Now, since the time control does most of the work for us, we are going to only implement a couple of variables that we can set here. So add serialized field, and we are going to create private float freeze time delay. Let's set it to be 0.01f by default. Okay. We can add here a unfreeze time delay. Let's set it to be 0.02f. So we want it to be a little bit longer than the freeze time delay. And of course, when we start, we can set the time freeze time delay to be 0 and unfreeze time to be greater. So we have instant time freeze and then unfreeze it after some time. Okay, let's create another serialized field. And this time, let's set the range. So range, and from 0 to 1, since our timescale cannot be outside of this range, let's create private float time freeze value. And let's set it to be something like 0.2f. So this will be the time freeze value that we want to set to our time scale. Now, all we have to do is in our complete previous feedback, let's simply call our time the controller. And since this is a singleton, we're going to call .instance, and now we have access to the only instance of our time controller. So our instance .reset timescale. And you might already see that if the second enemy will be hit, we are going to reset the timescale, stop all coroutines, and restart the coroutine. So our first enemy has freeze the time, and then the second time will reset the effect of the previous enemy and restart the freeze cycle, so that we have this continuous effect of the time freezing, instead of freezing time, unfreezing, and freezing again, or having some difficulties with the apprehension of what is going on with our time scale. So that's why it was important to create the time controller singleton. Now, for our create feedback, what we will want to do is simply call our time controller .instance, again accessing the singleton .modify timescale, and we are going to call our time freeze value. I think it was the first end time value. Yeah, this was this. Maybe I should have renamed it. Time to wait will be freeze time delay, and our callback will be simply a lambda expression, so anonymous function. So brackets equal greater sign, so the lambda expression, and we are going to again call time controller .instance, and we want to unfreeze time, so we are going to call modify timescale, and we are going to pass the end value as 1 and unfreeze time delay for the delay, and we have no on finish on end callback, I think it was on complete callback, so we want to just set it to be 1 and then leave it at that. Okay, and I can see that I have made a mistake here. What we want to pass here is time freeze value. Okay, so what is going on here is we are going to modify the timescale to time freeze value, so 0.2f will be the timescale value, and we are going to do it by after the freeze time delay, which could be as well 0. So instantly we are going to set the timescale to be 0.2 to create this time freeze effect, and then after the freeze time delay we are going to wait unfreeze time delay. So this will be in this case 0.02f seconds, and then we are going to restart this reset this time scale to be 1 to return the time to the normal scale. Okay, let's save it. Let's go back to Unity. Great. And basically what we want to do is select any enemy chart. Just remember which one of those was it. Choose the feedback hit, and we are going to drag here time freeze feedback. Use those 3 dots to move it up, and we now see that we need to open the prefab, so let's do this. Okay, we are in the prefab feedback hit. Let's add the time freeze feedback again. Choose those 3 dots, move it up, and now we can drag this time freeze feedback to our feedback player, to the list feedback to play. Great. And now we can set it. Let's set the freeze time delay to be something like 0.001, so very small, and the unfreeze time to 0.02. Let's leave it at that, and let's freeze it to something like 0.1 for example. Now we can go back or Ctrl S to save the prefab, or go back using this arrow underneath the hierarchy to go back to our scene view. Now our one enemy that we have changed has this feedback hit and it has 2 time freeze feedbacks. So let's remove the additional one that we have added here, and now every enemy should have this additional time freeze time feedback in its feedback hit. So we have applied it to all the prefabs. So now if we press play, you should see that our enemies should freeze for a bit. Now if you don't see it, we can restart the game, but beforehand, choosing one of those enemies, choose the feedback hit and increase the unfreeze time delay to something bigger, like 0.1. Let's save it, and actually what we can do is go to our enemy chart that you have modified, overrides, and apply all overrides. Now if we press play, we should see that it looks more like the game is framing, but the time freeze is here. Choose enemy feedback, and let's set it to be 0.02. And this I think was good enough. Enemy chart, overrides, apply to all. Now let's press play, and now we should see that this is very subtle. The gameplay isn't very affected, but we have this feedback and it is visible, and I think it works pretty good for our purposes. Great, it was a lengthy video. Sorry about that. And before we go, we have a small issue with our time controller. So apparently when we stop the editor, so if we go to our, if we leave enemies intact, if we stop the editor, there will be the missing reference exception. And if we go down and click on the last, on the second to last blue line, it will give us the information that our complete previous feedback couldn't find the controller.instance. And the issue is because in our feedback class, we are calling this onDestroy, and onDestroy we are calling the complete previous feedback. And in our time freeze feedback, our time controller is already non-existing when we destroy our enemies. And the order of destruction is dependent upon Unity, so we cannot really do much about it. But what we can do is we can copy this line and create an if statement if our time controller.instance is not equal to null, and only then we are going to call on our time controller.instance.reset timescale. Ctrl-K, Ctrl-D to format this if statement, or you can use it with spacebar. In any case, this should fix our error. So let's save it. Let's go back to Unity. Okay, I'm going to press play. Now, we could kill one of those enemies, and if we have, and another one could kill us, beforehand it would throw 3 exceptions when we stop the game. Now there is no exceptions because we are checking if the time controller is not null before we're calling on it the complete feedback. Okay, so if that's done, in the next video we are going to implement a simple death animation for our player, because right now our player just simply disappears. So see you in the next video. In the previous video, we have added this time freeze effect that allows us to shoot at the enemies, and for a split second the time freezes, gives us a bit of anticipation. So this may be something that you want to implement, but by applying a too big of a value to it, you might achieve a different effect of framing rather than the effect of time freeze. So be careful when tweaking this effect. Right now, what we would like to have is we would like to have some kind of death effect, because currently it just disappears from our map. We can create a simple animation. So let's stop the game, and what we are going to do is we are going to go to our animation. If you don't have it opened, you can go to Window, Animations, and open the animation. Okay, with this window opened, we want to go to our player in the hierarchy, choose the avatar, and now we should be able to see our animations. So we would like to add a new clip here, create a clip. And we would like to choose underscore animations, our player, and let's call it death, player death maybe. Okay, let's create this animation. Now it is totally up to you how you want the animation to play. What I would like to create is flying upwards and to the back a bit, so rotating and up, and then flying back on the ground. So what we can do is add properties to our animation. Choose add properties and choose our transform, position, and add another property, transform and rotation. Great. Now, after some time, so maybe around 15 seconds, I would like the player to be up here. So I'm going to press this red button, enable disable keyframe recording mode, and I'm going to make our player a little bit higher, a little bit backwards, and I'm going to choose our rotation tool, and rotate it a bit. So for now what we have is our enemy will fly upwards and at an angle. So after going from here, I would like to be back at the ground. So I'm going to use move tool, move the player a bit backwards. I'm going to use rotation tool, and I'm going to rotate our player. Actually, we can use the transform rotation for it, or we can leave it like this, and make sure that your player is on the ground. You can swap the axis to be on the global position using this icon here at the top. We can swap local with global, and now we can move our player downwards. So make sure that our player is on the same level as it was previously. And now let's play this animation. And this would be our death animation. Now, of course, we do not want it to loop, but basically that's what we are going to do. Now, another thing that I would like to do, let's stop it. I would like to have this animation and have this player sprite become a bit darker each time. So I'm going to add property, sprite render, and color, for example. We can again press the record button and set the color to be white again. So this will be a white. And then at the end, when our player is lying on the ground, I'm going to choose the color and make it a bit darker, something like this. So now let's disable the gizmos. And of course we have our gun, and we cannot really disable our gun through the animation, so we will need to disable it through the script. And last thing I think we could use is let's uncheck this record button, and what we have is the default sprite for idle animation. Instead, what I would like to do is I would like to go to our project section, sprites, and I believe that inside our characters, our heroes, we have two more animations for our heroine. This is walk animation, this is jump animation. So I would like to swap it for the jump animation instead of for the default animation. And now our character should have this jump animation, and now it looks pretty good. What we can do is we can select our record button, because now our character is higher because of this animation. So what we can do is select our player avatar and change the maybe we can lower simply the Y and X to make it a bit closer. Okay, and this will be something like this. And now our player can be lower at the start, higher, and back on her back, and this will be the death animation for us. Let's uncheck the record button and see how it looks. Okay, this looks pretty good. Of course, we will be able to add an event here, so we can maybe reset our game, but for now, that is it. Let's stop playing the animation, and what we can do is we can make sure that we can play this animation. So let's go to our animator. Again, if you cannot find it, go to Window, Animations, and Animator. Now in our animator, we would like to enter the player death state from any state, so let's drag it a bit higher. Click on the any state, right click, make transition, and drag it to our player death. Let's add a parameter. Let's use this plus icon. Let's choose trigger, and let's trigger death. So death with capital D. Now we will need to remember this because we will reuse it in our script. Now before we finish, let's go to our project and underscore animations and choose our player death, and make sure that the loop time is off. So we do not want to loop in this animation. Great. Now this is the setup for our animation. And I can see the warning that this transition doesn't have any condition. So I'm going to choose the transition inside our animator from the any state to the player death, and I'm going to make sure that the condition is our trigger, our death trigger. Great. Now we should be able to transition to this player death state. Make sure that the has exit time is disabled. Setting, let's reset the transition duration to 0. Now we should be able to transition to this death state immediately. Now with that done, you might be wondering what happens if with our override for the enemy. So if we go to our underscore animations and check our enemy animator, we can see that it has a space for the player death animation. So we could as well implement a player death animation for our enemy, but we are not going to use this. For the enemy, we are going to use the effects. But for the player, we are going to make sure that we can trigger this player death animation. So make sure that you double tap on this death or copy this trigger, so we are going to use it. And what we can do is either we can go to our underscore scripts folder and open up the agent animations. So double tap on it to open it up in Visual Studio. Great. Let's slide it down, and we are going to want to create a public void play death animation. And what we are going to do is we are going to call agent animator.set trigger and open brackets in the quotation marks, paste the name of your trigger. For me it was death. Okay, great. And this will be it. So let's save it. Let's go back to Unity. Okay, so now let's go to our scene view and game view. And the easiest way to assign it would be to go to our player. And so now, right now, our player plays only on death sound. And if we click those 3 dots near the player script and edit the script, let's see how the death animation is being played. Okay, we are inside the player script. Let's slide it down, and we have this death coroutine. Now we do not want that, so let's delete this coroutine actually, and let's stop the coroutine from playing. Since we have been waiting for a bit until the death sound is finished playing until we disable our player. Now, what we would like to have here is instead, we would like to rely on this on-die event. Let's save it and let's go back to Unity. Great. What I would like to do is I would like to assign a new event to our on-die inside the player script. So let's add an event listener. Let's drag our avatar and let's choose from our avatar the animator, so agent animations, and let's choose the play death animation. I think, play death animation. Let's try playing and let's see what happens. Okay, we can see that our enemy stopped attacking our player. Our player can still move, so this is an issue, and we have still the gun. So we need to include all of those in our event. So let's stop the game and let's assign some more event listeners to our on death. So for sure, what we would like to do is play the death sound, play the animation, and let's add another listener, and let's assign the player this time. Let's choose the function, agent input, and bool enable. So we're going to basically disable the agent input for the player. So this will prevent us from moving our player. So now if we press play and if we stand still, and we cannot really shoot or we cannot really move our weapon. So again, we would like to add another event and choose our weapon parent. And actually we would like to choose our weapon assault rifle. So select our player, drag our assault rifle and choose the game object, and we should have the set active bool to false. So now if we press play, our weapon should disappear. Okay, now that is great. We cannot really shoot, we cannot really move. The issue appears when we are moving constantly, and since this is a game about moving and shooting, our player will still keep on moving and will stop at some collider. So we do not want that. We are going to open up our agent movement script. So let's select it from either our underscore scripts folder agent movement, or click on those three dots near the agent movement inside our player. So let's open the script up. Great. Let's slide it down and let's create a public method. Public void stop immediately. And this method simply will stop our rigid body from moving. So what we can do is, since we are setting our rigid body in the fixed update to be rigid body.velocity equals current velocity times movement direction.normalize, we are going to simply set the current velocity equals 0. And what we can do is set our rigid body dot velocity equals vector2.0. Okay, and now let's save it. Let's go back to Unity. Great. Let's add another listener to our on death event, and we are going to simply drag our player, choose our agent movement, and select our stop immediately. Now if we press play, we should see that even if we are moving, our player stops. We do not have any control over what is going on. The enemy stops, and now we could as well have some kind of event added to our animation that would show us a main menu or restart the game. For now, we are not going to bother with this part. Let's continue. We haven't yet implemented all the features of the feedback that I want to implement. So in the next video, I'm going to show you the version of the game that I have presented to some playtesters, and we are going to analyze what have they said about the version. This is very similar to what we have so far, and we are going to, based on their feedback, implement some more features. So see you in the next video. In the previous video, we have added feedback to our player, so when our player is killed, our player plays an animation and the sprite becomes darker and we cannot really shoot anymore or do anything, and that is okay for now. What I would like to do now is, since we have this mechanic for shooting the enemy, it looks pretty good. I would like to show you the version of the game that I have published for the feedback from some people from the game dev community, and they have gave me some feedback about the mechanics. Great. So on the /GameDev Reddit, I have asked three simple questions. Does the shooting feel satisfying? Is it clear when enemy get hit? And is it difficult to kill a monster? kill all monsters. So I'm going to show you the version that I have posted for this. Okay, let's see it. So this is the version of the game, and you can already see that the monsters are being kind of spongy. I need to go back constantly to kill them. I can already see that this was a mistake giving those enemies so much health. So let's see the feedback from the people that have actually played this prototype. I have extracted some feedback from the Reddit posts that I have received about the game. So first feedback, there is this sentence that is of interest to us. I felt like there was too much screen shake and enemies took way too long to die. So you can see already that our feedback in form of screen shake was too intense for someone, and that the enemies had too much health. And you can see from the gameplay that indeed this was true. They had about 5 or 6 health points, and there was a small bug with the bullets. Next, the second feedback I have received felt pretty good for the prototype. As the other users noted, enemies are too spongy, so the second case that the user has spotted it, so this might be an issue for us. We have fixed it using the lower health for our prototype, but you can see already that it is very important to test the game before you release it. Enemies clumped together are too easy to kite. So I think the issue was that there was no collider on enemies, and since they were very close together and they had the same speed, they have clumped together, and since they were so spongy and there was no knockback, it seemed like it is one big enemy and you didn't know who you were shooting. So the screen shake is nice, but one thing that makes the bullet feel weak is the lack of knockback. So you can see that we should probably implement a knockback effect, and in general too easy for this person. Next, we slide down and we have third person commenting, does the shooting feel satisfying? I believe what would help is if my shots felt like they had more impact. Is it clear when the enemy gets hit? Not really. I noticed that enemy flash wide, but this is more difficult when they are in the large group. So we can see that the not noticing which enemy is hit is due to, first, the lack of colliders on the enemies, so they clump in big groups, and the lack of knockback effect, so that we can separate the enemy that we are shooting, and rather they stick on in a group and we do not see much of the effect. So we essentially need to add this knockback effect. Now the last two points are pretty interesting, because one person has said that this is not easy or difficult for me, and the limited space to move around made this game feel more difficult, but the character felt like she could move reasonably fast. Now the next person said, it is only slightly annoying that the player is about the same speed as the enemies. So you can already see that the different people can perceive the speed that your enemy and player are moving in the different ways. So those are the issues that you might face. Is player too slow? Are enemies too fast? And maybe iterate over those ideas, because right now we do not have a clear answer of what does the player want. Now, I will post a link to the game that I have presented to you, so you can play it on your own and check out what are the issues. But just let me tell you that it is pretty vital that you get the feedback, because when I was creating this version of the game, I was almost done with it, and I have presented it to the people just to get the feedback for this course so we can discuss it. But as well, I felt pretty differently that I feel now about the game after some time has passed. So the issues that I can see right now wasn't clear to me then, and it was caused by the bias of the creator. You might read more about the psychology of this whole thing, but basically when you create something, you feel responsible and you feel good about it. Despite the fact that it has obvious flaws, it is best to ask people for feedback. Okay, see you in the next video. In the previous video, we have analyzed some testers' feedback. So in our underscore data folder, in enemy data, in enemy chart data, we can control the health of the enemy and the damage that it does. And in enemy chart movement data, we can control the max speed and the acceleration, deceleration for the enemies. As well as we can see in underscore data the player movement data. And we can create those using right click, create, and we have this weapon data and enemy data and agent data. So we have the control over all of those parameters, and we can always make the changes. Now, another thing that we wanted to change was to add the knockback effect. So how do we go about it? Well, since this is connected with the movement, and it will rely on the us modifying the way that the rigid body behaves, I think the best way is just go to _scripts folder and modify our agent movement a bit to add this knockback possibility. So let's open our agent movement script. Great. We are in our agent movement class. We will need to add a way for us to add a knockback. And I think we will need to have a way to set a boolean flag if we are knocked back, because when we are using our rigid body to move our player, our enemy, or our player as well, this sets in the fixed update the rigid body.velocity. But when we want to inflict knockback, we want to modify this velocity and keep the enemy still after it is knocked back. So we will need to have a way to influence how this code behaves. So let's slide up underneath the movement direction. Let's create a new field, protected bool. Let's call it is knocked back. And let's set it to be false by default. Let's save it. Now, what we are going to do is we are going to slide down to find the fixed update. Make sure that we call this onVelocity change because our renderer relies on it. But then before we call the rigid body 2d.velocity, we are going to check if our is knocked back boolean flag is equal to false. So only if the flag is false, we want to drive our enemy using the input. Else, we are going to drive it using a different function. So let's slide down under the stop immediately. We are going to create public void knock back. And this will take a vector2 direction, since we need to know in which direction should we knock back the enemy. Next, we are going to add float power, and we are going to add a float duration. Since we want to know how long should the enemy be knocked back. Okay. And now we are going to check if is knocked back is equal to false. Only then we are going to be able to inflict another knockback, so it doesn't accumulate, so we are knocking and knocking and knocking back the enemy, since we are going to use a coroutine to knock the enemy. We are going to set is knocked back boolean flag to true, and we are going to call a coroutine. So let's slide down, and we are going to basically do the same formula as we did for the feedback. So we will need to have a public void reset knockback, and this function will simply reset our knockback, so stop all coroutines. And actually we may want to stop the concrete coroutine because we may have different coroutines in our agent movement. So let's set for now is knocked back equals false, so we reset our boolean flag, and let's create our coroutine. So I enumerator, let's call it knockback coroutine. And let's pass to it our vector2. Actually, we can copy the parameters from the knockback function because we are going to pass them down the line. And let's paste them into our knockback coroutine. And let's open the parentheses for this coroutine. What we are going to do is we are going to call rigid body dot. And how do we knock our enemy back? The easiest way is to add a force. So let's see the documentation for it. Great, we are in the rigid body documentation for Unity, and we can see that adds a force to the rigid body, this add force method. Let's go back to Visual Studio. Now, if you don't have the tips, you can control space to bring back the IntelliSense tips for the methods that we can apply to our rigid body 2D. And we want to apply the add force. And what we are going to do is we are going to call the direction dot normalized. So we want to have the normalized direction times the power of our force that we want to add, so the power of the knockback. And we are going to set the force mode dot, and we want to have an impulse, which basically adds an instance force to our rigid body, so it will be instantly pushed back with the full force that we want to apply to it. Okay, and next we are going to wait yield return new wait 4 seconds, So this will be affected by the time scale that we are changing using the time freeze feedback. And we are going to pass the duration, since we want to have a control over how long the knockback lasts, because maybe you want to have different weapons, different bullets that causes different kind of knockbacks, and maybe it will be the part of the balancing for your game that you will do. Okay, next, what we want to do is we want to reset our current velocity, since this is the driving factor for our rigid body. We are going to set our rigid body dot velocity equals vector 2.0, and lastly we want to reset our flag is knocked back equals false. So probably we could do those two things as well in our reset knockback. So let's paste it, or we can extract it into a separate method, and those three parameters. So let's right click on it, quick action, and extract, and let's call it reset knock back. And we have this method, so reset knockback parameters. Okay, and we are going to simply copy this method and paste it inside our reset knockback function. And I believe what we could do is, instead of stop all coroutines, we could call stop coroutine, and either paste the name of this coroutine to stop this concrete coroutine if you have more coroutines, or save what is returned from this knockback coroutine into a separate parameter and stop this concrete coroutine in case you have more coroutines in your agent movement script. Okay, let's go back to Unity. Great. Now, since we have implemented the changes to our agent movement, the knockback, we would have to call it from somewhere. And to drive the power and duration and direction especially, we have hard time creating a feedback class for it. So what we are going to do is we are going to implement an interface. So let's go to our script _ scripts interfaces, right click, create C# script, and we are going to call it knockback. And let's open this script up. Great. Let's delete the update and start method. And as I have previously mentioned, this will be an interface that will allow us to define who can be knocked back, and thus we are going to be able to use our functionality. So let's change the class keyword to interface. Let's delete the monobehavior inheritance, and a single method will be void knock back, and we are going to pass here the vector 2 direction, float power, and float duration. Okay, and this will be our method that we want to implement. Now let's go back to Unity. Great. And where do we implement this interface? Well, we are going to use our sprites, _ scripts, and we are going to go to enemies and open up the enemy class. Great. What we can do is we can add knockback interface to the definition of this class, and alt enter on it and implement this interface into our enemy class. Now, of course, if our enemy implements this knockback, we are going to need to have a way to access our agent movement. So what we will need to do is we are going to have a reference to our agent movement script. So let's slide it down, actually above the events. So just below the bool dead flag, we are going to create private agent movement. Let's call it agent movement. Okay. What we are going to do is, of course, we could create a separate event that would call such a method or pass those parameters, and then we would just assign our method. But instead, we are going to just use the old-fashioned way of getting the reference to our agent movement. So we are going to do it in the awake. After getting the enemy attack, we are going to call agent movement equals, we are going to call get component, and type will be agent movement, and that will be it. Great. Now let's slide down to where our newly created method is, and instead of throwing exception in the knockback function, we are going to call our agent movement dot knockback, and we are going to pass the direction, we are going to pass the power, and we are going to pass the duration. Okay, so let's save it, and again we will need to go back to Unity. Great. Again, in underscore scripts, let's find the weapons folder and let's open up the regular bullet script. Great! Now what we can do is slide down and we have two options. We can call this on trigger enter to do, and we can find the I knockback and call the method on the knockback, but as well we can do it only when we hit the enemy. So I will in hit enemy method call var knockback equals our collision dot get component, and we are going to type I knockback interface name. If we find it, so knockback question mark dot, we are going to call knockback, and what we want to paste as the direction is simply the transform dot right of our bullet. Since if our bullet is traveling always to the right of its local position, so we will pass this direction, so the enemy will be knocked back in the direction that the bullet was flying. Next, for the power and duration, I think we have our bullet data with capital B, bullet data dot knockback power, and we have our bullet data dot knockback duration or delay. And this we have implemented a while ago when we have created the data for our bullet. So we have all the necessary steps covered. Let's save it. Let's go back to Unity. Great. Let's slide up in the project section. Let's open our data, weapon data, and let's check the bullet data for our regular bullet and what are the parameters for the knockback power and delay. Okay, I think those are decent enough. So let's press play and let's see if it works. And I'm afraid it doesn't, because I have forgotten to call the start coroutine in our agent movement. So let's slide down to our underscore scripts folder in the project section. Let's reopen our agent movement script. Okay. And I have forgotten to call in our knockback method. If you can't find it, use the drop down list from the top right corner. And we have knockback coroutine and knockback. Let's go to the knockback method. And here, well, I have forgotten to call our start coroutine. And we should call our knockback coroutine. Okay, we need to pass here the direction, the power, and the duration. Let's make sure that we save all scripts using Ctrl-Shift-S, and let's go back to Unity. Great! Let's press play, and let's see. And you can see that our knockback works. Even if our enemy is charging at us, we can knock it backwards, and hopefully give our player a bit more space to defend. In the next video, we are going to add bullet shells so that when we are shooting, I would like to generate bullet shells around our player. We are going to talk about object pooling that we can use to limit the number of bullet shells that will be visible. And basically that's what we're going to do in the next video. So see you there. In the previous video, we have implemented the knockback to our game so we can knock our enemies back even if they are running at us, so it looks pretty good. Now what I would like to do is also spawn bullets, or rather bullet shells, when we are shooting, so that possibly we can give our player a little bit more feedback and it is more pleasant to see our bullet shells flying from our guns. What we want to do is we want to implement object pooling technique, which will mean that we'll limit the number of our spawned items. So let's explore what the object pooling is. Okay, we are looking at the game programming patterns. I will link this article in the description of this video, in the resource section of this video. So the object pool improve performance and memory use by reusing objects from a fixed pool instead of allocating and freeing them individually. So basically what we want to do is we want to create some number of our bullet shells, and instead of destroying them and recreating them, which could possibly create more overhead on the CPU, we are going to instead reuse the old bullets by teleporting them from the last position, so from somewhere where they were spawned first, and spawn it in a new place. Okay. So what we want to do is we want to create a generic object pool class that we will reuse across the project, or rather we are going to use it inside the bullet shell script to reuse the bullet shells, but you can implement it for your bullets as well. So we are going to open up our underscore scripts folder and right click here and create new C# script. Let's call it object pool. And let's open this script up. Great. Now this will be a custom data class. So let's delete the update and start methods. We are going to leave the mono behavior since we are going to use it on our bullet or rather bullet shell spawner, and we are going to simply attach it to where it is needed. So we are going to create a serialized field, and let's create a protected game object, and this will be the object to spawn. Since we will always want to spawn a certain object. Next, we will need to have some parameters for our object pool, so serialized field, and let's create protected int pool size. So this will be the size of our pool from which we are going to create this amount of objects, and if we want to create one more, we are going to reuse the last or first created object for the new object instead of recreating it from scratch. Great. Next we are going to create a protected int current size. Since if our size is less than max size, so the pool size, we are going to keep creating new objects. If the current size is greater, then we are going to start reusing the object, and the data structure that will hold all of it will be protected queue. And let's add here a type of game object, since this will be the generic queue object pool. The queue is a data structure that is characterized by being the first in, first out. So the first object that gets in is the first that gets out. So if we place here the object to spawn and we have a size for 10 objects, if we already have 10 objects in our queue, the first object, so the oldest one, will be reused first before we go to the next one. Okay, let's create awake, and we are going to create our queue, so object pool equals our new queue of game objects. Okay. And last method that we will need is just a method to spawn objects. So let's create public virtual game object, since this will return our game object, spawn object, and we are going to pass here our game object current object equals null, and this will give us the opportunity to pass to our queue an object, rather by setting it through this game object. So what we can do is we are going to call if our current object, so this is the one that we have passed here, is equal to null. We are going to set simply the current object. So this will be equal to our object to spawn. Great. Now, what we want to do is we want to create a temporary game object. Let's call it spawned object equals null. So this will be the object that we want to spawn. Now we are going to have two cases. If our current size is less than pool size, then it means that we can create more objects, so we can simply add a new object and instantiate it. Else, this will mean that we have a full queue and we want to reuse the first object, so the oldest object from the queue. So first of all, our current size is less than pool size. We are going to call our spawn object equals instantiate, and we are going to simply instantiate our current object, be it the one that we have passed to this method or the one that we have passed in the inspector. Next, we are going to call transform.position, so this will be the position of our gun, and we are going to call quaternion.identity as the rotation. And next, we are going to call spawned object, so this is the object that we will return, .name, and we are going to name it so that we know exactly which one is which object is which, so that we know that first of all our queue or our object pool work, and the next that we can select which object is which, so we know exactly what is going on. So let's call it current object.name, so we want to have the name of the object, plus quotation mark underscore, another plus, and let's add the current size. So we are going to make sure that we rename it. And next we are going to increase the current size. Great. Else, if our current size is greater than the pool size or equal to it, we are going to call spawn object equals our object pool, so our queue, and we are going to call on it the queue, which simply gets the first element that was added to the queue, so the oldest element. Now we are going to call again our spawn object dot transform dot position equals transform dot position, so the position of our object pool, and spawned object transform dot rotation, we want to reset it to be quaternion dot identity. Now bear in mind that we are not checking if the object is enabled or disabled, because we are going to use it for our bullet shells which stays enabled. But if we want to perform such actions, we are going to need to do it when we call spawn object. When we get this object, we are going to need to enable it in the class that uses this object pool. Okay, next what we are going to do is we are going to simply call our object pool. Since we have dequeued our spawned object in the else statement, it isn't currently in our queue. So we need to enqueue whatever we have received, either the new instance or the old instance. We need to enqueue it, so spawned object enqueue spawned object into our queue, and we are going to simply return our spawned object. And that's it for our object pool, our custom class. So let's save it. Let's go back to Unity. Great! In the next video, let's create our bullet shell generator and implement it into our game. See you there! In the previous video, we have created our custom object pool script. Nothing fancy yet, but now in this video, let's use it for our bullet shell generator. We will need to create a bullet shell generator script. So let's go to _scripts folder. Another question is, where should we put it? I think it is connected mostly with the feedback, so we are going to create it in our feedback folder. So let's right click, create a new C# script, and let's call it bullet shell generator. Let's open up the script in Visual Studio. Okay, so what we will need to do here is we are going to delete the update and start methods. And instead of mono behavior, we are going to implement or extend our object pool. Since we have left it as a mono behavior, we are going to still be able to attach this bullet shell generator to a game object inside our hierarchy. Now, what I would like to make here is I would like to make it spawn bullets around our player, and at the same time I would like to use some kind of rotation and movement so the bullets fly from our player or from our gun downwards, or at least not upwards from our position for the player. So to do that, we are going to implement a serialized field, and let's call it private float fly duration, and let's set it to be 0.3f, for example. And again, we are going to add a serialized field, private float, and let's call it fly strength. Okay, let's set it to be 1 for now. Now to spawn our bullets, we are going to use our Unity events. Since we have our onShoot event, so we will be able to call a method then. So let's create public void spawn bullet shell. Okay, and we want to get the var shell equals our spawn object from our object pool class. So this method will give us the shell. We are going to provide a shell prefab, and we are going to create it after we finish the script. And we are going to provide it to our object pool. I think it was object to spawn. Next, what we will need to do is we are going to perform some movement of this shell. So we want it to kind of rotate around and move in some direction from our gun. So to do this, we are going to create move shell in random direction. Okay, we do not have this method, but we are going to pass here shell. Okay, move shell in random direction. Alt enter on it, generate this method inside our class. And here we are going to perform all the operations on it. So first of all, we will need to have a direction in which we want to spawn our bullet. And we are going to use our doTween library to tween our bullet towards some position and to rotate it so it looks like our bullet is actually flying away out of our gun. So let's call shell. This will be the shell object that we have passed here. Dot transform, and we are going to call do complete. We do not have this because we have not imported the library, so Alt-Enter on it, and we'll be able to say using dg.tweening, so this is our doTween library. And now we are going to perform some transformations or some tweening on the transform of our shell. So first of all, we will need to have a random direction in which we want to make our bullet fly. So let's call var random direction equals random, and this will need to be our Unity random. So Alt-Enter on it, and we can see that this is Unity engine.random, or what we can do is delete it and at the top of it, and what we can say here is using random equals Unity engine.random. And now all our calls to random will go to our Unity engine.random library. So random dot, and we are going to call inside unit, and not sphere but circle. So this method generates a random point inside a circle with radius 1. That is great for us because we want to have exactly that. Now, since we want to have this illusion of 3D, we only want to spawn our bullets below our player rather than above. So we do not want the bullet to fly upwards above the head of our player, but rather downwards toward the legs of our player, so it looks more believable. So to do that, we are going to call our random direction equals random direction dot y is greater than 0. So in case our direction points upwards somewhere, we are going to question mark it, and we are going to call new vector 2, and we are going to pass our random direction.x since x is okay, and comma and minus y. So we are going to simply turn it to point downwards. Else, we are going to keep the random direction as is. Okay, and we need to pass the random direction dot y in the first statement. Okay, so this basically will turn, if the bullet wants to fly upwards, we are going to turn it to fly downwards, and it will make the bullet fly either left, right, or anywhere in between in the downwards direction. And that's what I wanted to achieve with this statement. Next, we are going to call our shell.transform, and we are going to use doMove, which simply tweens the transform position to a given value. So we are going to start from the position of our weapon, where the bullet is being spawned, and we are going to move it in the direction vector 2. So we want to cast a transform dot position. So this will be the position of our gun plus our random direction. And this will be the direction at which we want to make our bullet fly. Next, what we want to do is we want to take it into brackets, this whole statement, because we want to multiply the vector of direction with the strength, so fly strength. And this will make our bullet fly with the strength that we provided inside our bullet shell generator. So this will decide how far the bullet flies. And we want to set the fly duration as the duration of our animation, of our tween. And now what we can do, what we can add to it is dot on complete, and with capital O. So this will be the callback to the on complete. What happens? And we will implement a simple audio sound so the shell hits the ground. So this will be on complete, and we are going to open brackets, open another bracket since we are using the lambda expression equals greater sign. So this will be in the anonymous function. And we are going to call shell. We are going to add here an audio source, so get component of type audio source. And we are going to add to this audio source a sound for the bullet to hit the ground. So I need to put it in triangular brackets, the type audio source. And if you get it, we are going to simply call play on it. And this will be it. Okay, finish this statement. And We could have created a sequence here as we did previously in one of the previous feedbacks, but instead we are going to simply apply another queen shell.transform, and we are going to simply call do rotate, which will allow, not restart, rotate, and do rotate will allow us to transform the rotation of our bullet. And we are going to simply randomly rotate our bullet from 0 to 360 degrees. So it will also rotate. So to do that, we are going to call new vector2, since this will be the end rotation. And we are going to pass the rotation in Euler angles. And we are going to pass 0 as x, 0 as y. And on z, we want to call random.range. And let's calculate the random from 0 to 360. And this will be the float value. So let's add f at the end of those values so that we know that it will be a float value. Okay. And at the end of the second brackets, after we define the new vector 2, we are going to call our fly duration so that the rotation lasts as long as we make the bullet fly to reach the end position. And I should have created vector 3 here instead of vector 2, because now it is complaining that we have z value. So vector 3, 0, 0, random.range 0 to 360. So this is the end rotation that we want to achieve. And this will be it for our bullet shell generator. So just save it. And let's go back to Unity. Okay. Now last thing that we have is to, first of all, create this object inside our player, inside our weapon parent assault rifle. So let's do this first. Right click here on the assault rifle, create empty. This will create a child inside our assault rifle game object. Let's rename it to bullet shell generator. And let's drag here our bullet shell generator script. All simply called add component bullet shell generator. It should be available. And we have our pool size. Let's set it to 50. We have our fly duration and fly strength. It can stay. And you might remember that we wanted to access the audio source. The audio source will be added on the object to spawn, so the prefab of type bullet shell. So let's create one. So let's create a new game object inside our hierarchy. Right click, create new, and let's rename it to be bullet shell. Okay. What we want to do is make sure that the transform is set to 0, 0, 0. Let's see. I'm going to click 3 dots and reset the transform. Next, what we want to do is we want to go to our project section, find out underscore sprites, open it up, open the HUD, and we should have this bullet shell prefab. So we are going to drag it into our bullet shell game object inside our hierarchy. Okay. And this should create us our bullet shell. Now this is invisible, so we are going to need to set the sorting layer. So let's choose default, let's choose the agents, and let's set it to be on the layer -1, so it will always be below our agent and our enemy. I think we are changing the enemy layer to -1 as well, so there might be some issues. So let's set it to -2, for example, just to make sure. And let's go back to our bullet shell, and let's add here audio source. So let's add audio source through the add component. And now we will need to choose a sound that we will want to play. So we are going to choose this cog icon near the audio clip, this type ammo. Okay, choose it. And let's select it in the audio source. It should point us to where it is. It is in underscore sounds in the sounds folder. Let's select it, let's play it. Okay, it is quite quiet, but it will give us the impression that our bullet shell has hit the ground, the floor. So let's go back to our hierarchy, select the bullet shell. Let's make sure that the audio source doesn't play on awake. And this should be it. We can leave the volume at 1 because it is quite quiet sound. Okay. So last thing is to create a prefab out of this bullet shell. So let's find our prefab folder. Let's drag our bullet shell into the prefab folder, into the prefabs. And we have our prefab for the bullet shell. Let's delete the bullet shell itself. And let's assign to our assault rifle inside our player game object to our bullet shell generator, our bullet shell. Now, of course, the last step is to assign our bullet shell generator to generate our bullet when we are shooting. So let's go to our assault rifle in our hierarchy, and here we should have our callbacks. So we have our weapon script, and on it we have our onShoot. And onShoot we want to add another listener, drag our bullet shell generator, and select from the function bullet shell generator, and we have our method called spawn bullet shell. So let's select it. Now, if we press play, let's see it. We should be dropping bullets in the downwards direction, or to the right or to the left, but never upwards. And this was the point with our random bullet direction. Keep on shooting. At some point, our bullets will start disappearing from this pile, and they will be appearing here when we are shooting. But since we are always looking at where we are shooting and at our player, it doesn't seem to be very visible for us to see that those bullets begin to disappear. Okay, anyways, that's it for our bullet generator. Last step is implementing some kind of music to our game. So see you in the next video. In the previous video, we have implemented the bullet shell generator so that we are generating the bullets when we are shooting, and we are using object pooling so that at some point those bullets that we have shot earlier, those bullet shells that were spawned earlier, will become invisible, or rather will be respawned at our position, so that we can reuse those and do not keep all of those bullet shells in the memory while we are fighting the enemies. Since if we play it correctly and create the gameplay that it will be involving, nobody will notice that some bullet shells disappeared. In any case, let's stop the game, and in this video, let's quickly implement a music in the background so that we have kind of lively scene before we go to the next section. So what we are going to do is simply right-click, create game object, and let's call it maybe background music. Okay. What we will need to do is add here component audio source. Great. Let's choose the sound using this cog icon near the audio clip. Let's type theme, and we should have theme 4. Let's click on it. Let's choose this from the project section. Let's try playing it. This is pretty loud, so we are going to definitely want to decrease the volume of it. So let's go back to the hierarchy, background music. Let's decrease the volume to something like 0.3. Make sure that it plays on awake for the background music, and also make sure that it loops. So let's press play, and now our music is playing. Our game is much more pleasant. So in the next section of this course, we are going to implement the spawning mechanics so we can spawn our enemies in the corners of the room so they come at us constantly, so we have some kind of prototype of our game. We are going to implement some kind of UI using the pixel font so it matches the style of our game. And we are going to connect it to our bullets for our weapon, so we know exactly how many bullets do we have, how much health do we have, and we are going to spawn some packs from our enemies so that we can pick up health and pick up ammo, and probably we are going to implement a way to restart our level when we die so that we have this constant gameplay, and this will be it for this course. So see you in the next section.